Good morning, students. Today we shall learn about a new chapter, that is the lesson 14, sources of energy. Now, in this chapter, what we shall study? We shall talk about the good sources of energy, conventional sources of energy, non-conventional sources of energy, as well as we shall talk about the other means of uses of the non-conventional sources of the energy, as well as we shall talk about the characteristics of the idle fuel and what are the ways by which we can conserve the resources, as well as what are the measures or how long will the energy source last for us or the human beings. Now, in ninth standard we have studied about that the energy can neither be created but it can be transformed from one form of energy to another. So in that case, once the energy is being used, it cannot be regained or reproduced back, children. Now, the first topic that we are going to study is about the properties of an idle fuel. Now, what are the properties? What amount of fuel should be used? There are all parameters we shall discuss in the next video. Now, what are the properties of an idle fuel? The first point says that performs a large amount of work in less volume or mass. Meaning, if you take 100 gram of wood, it should burn completely, and the other thing is that it should produce a large amount of fuel. Now, it should not that if you take a large amount of fuel and it produces less amount of energy. No, it should not be. Now, the next thing, that is, it should be easily accessible. Now, a fuel that you use, it should be easily accessible and should be easily available also. For that, we need to keep in mind the type of fuel that we use and the modes of its accessibility. Now, the third one, economical. Now, what's the point if the fuel is not economical? Meaning, what if it's so expensive? What if 100 gram of fuel can fetch you 1,000 amount of rupees? It should not be. So, the type of fuel that you use, it should be economical. Now, the next point says that it should be easy to store and transport. Meaning, a fuel that you use, it should be easy to store, like in some container or in some out of what you can say, the other type of the handlers, and it should be easily transport. Now, it should not be flammable or it should not be hazardous to the health of an individual or the human beings or any other, we can say, the organism. Now, the third one, that is, it should be low and convenient point of combustion. Meaning, as long as the fuel is being, what you can say, used up, or you can say it is being searched, it should be having the convenient, or it should have the low ignition combustion. Meaning, the temperature at which the fuel burns, it should have a low ignition temperature. Now, you are all well aware about the ignition temperature, children. Now, the last point, that is, it should be culturally acceptable. Meaning, in a society where, in this, not talking about our regional society but to the worldwide, it should be culturally acceptable by all the human beings, so that it does not pollute the environment, it does not poses a threat to the other organisms also. For that reason, these are all the characteristics that we have discussed so far, that is the properties of an, we can say, idle fuel. Now, the first topic that we are going to study over here is the types of resources, and in that we shall discuss about the conventional resources, children. Now, conventional resources are those resources which are, we can say, accumulated in nature for a very long period of time by the degradation of the dead remains of plants and the animals, as well as these resources, that is the conventional resources, they are non-renewable. Meaning, that is, they take thousands of years to regenerate, meaning they are non-renewable source of energy, and for that they have to be kept in mind and judiciously used, we can say. Now amongst that, they are also available in limited quantity in the nature, and for that we need to use it judiciously. So these are the three characteristics of, we can say, what the conventional sources of the energy. Now the next, that is the type of resources, that is again the non-conventional sources of the energy. Previously we had talked about the conventional sources of the energy. Now the non-conventional sources of the energy, their properties are, the first of all, that is, they are inexhaustible, meaning you can use again and again this type of resources with the help of the nature and the use of the non-conventional sources. The next point, that is, they regenerate, that is, they are being reproduced again in a short period of time. And the other one, that is, they are pollution free or low polluting during the conversion, meaning once these resources they are being produced, they produce a less amount of pollution when they degrade into the environment back. As a result, it does not harm the other organisms also, and the other organisms which are using it. And the fourth point is that they are used to produce energy again and again, meaning this energy are easily available and they can be used again and again from time to time, and with the higher efficiency also, children. So these are all the characteristics of the non-conventional sources of the energy, children. Now as we have talked about the conventional sources of the energy, we shall talk about the examples. The first of all, that is the fossil fuels, and the next one, that is the firewoods, and the third one, that is the nuclear energy, which includes the nuclear fission and the fusion. Now nuclear fission means to break and fusion means to combine. Like in fission, if you break a big stone into small pebbles, it is nuclear fission. Wherein if you take small pebbles and you join it to become a larger stone, that is the example of nuclear fusion. So these are the, what I can say, examples of the conventional sources of the energy, that is the fossil fuels, the firewoods, and the, we can say, nuclear energy. Now in the next, that is, we will be talking about the non-conventional sources of the energy. Now the non-conventional sources of energy, that is the examples that we have in front of you, is about the hydroelectrical energy, the biomass energy, the wind energy, the solar energy, geothermal energy, tidal energy, and OTEC, that is other type of energy sources, we can say. So in that case, we shall talk about one by one the hydroelectric, biomass, wind, solar. Now and the other form of energy. Now we all know about the hydroelectric, meaning the energy which is being produced by the hydroelectric stations, that is the dams and all those things. Biomass, like the dead remains of the animals and the plants which are being decayed in the earth's underground soil. Wind energy, by the use of the wind turbines. Solar energy, with the help of solar energy, and the geothermal energy as well, and the tidal energy because of causing the tides, we can say, children. Now the first type of the conventional sources of the energy, that is the fossil fuels. Now first of all, what do you understand by fossils, children? Fossils are nothing but the dead remains of plants and animals which are about to decompose in the soil. That is, they are known as the fossil fuels, children. Now these fossil fuels are being formed over a long period, we can say, or we can say thousands of years, in which the animals and the plants have been buried, but they are not being degraded completely, children. Now the characteristics of the fossil fuels, that is, they are, we can say, non-renewable sources of energy, so we need to conserve them. The other one, that is they are biotic in origin. Biotic meaning they are being formed by the living organism, like the dead remains of plants and the animals, children, we can say. Now they have the property to have the acid rains. Now what do you mean by acid rains, children? Many a times, due to the non-biodegradability of these substances or the biotic substances of the fossils, some amount of gases they are being released, and when these gases they go up into the atmosphere, when combined with the droplets of the water, that is rain, and when they come down again in the form of rain, they lead to, we can say, acid rain, which are very very harmful for the organism, children. Every organism, meaning the plants, the animals, the humans as well, we can say. Now also it causes the soil and the air pollution. Now why it does? Because it leads to the infertility of the soil erosion, we can say. It causes the air pollution by releasing the harmful gases into the atmosphere, children. Now so this is all about the, we can say, the fossil fuels. Now what are the harmful gases that they lead to, we can say? That is, they lead to the oxides of carbon, nitrogen and sulfur, we can say. Now moving on to the type of the fossil fuels, that is the three types of, that is the coal, then the petroleum, and the other one, that is the natural gas, children. Now interestingly, these fossil fuels are being, we can say, produced by the actions of the pressurized gases or inavailability of the oxygen in the earth crust, children. Okay, and so for that reason we need to understand that they are non-renewable sources of the energy. And the type of fossil fuels that we'll study, that is the coal, petroleum as well as the natural gas, children. Now the first type of the conventional sources of energy, that is the coal. Now coal is being formed by what, children? It is being formed by the degradation of the dead remains of plants and the animals, which is being buried in the earth crust. But due to the high pressurized gases, this coal is being classified into four types, that is the bituminous, anthracite, peat and the lignite. Now based on the carbon composition, these four types of coals are being used commercially for different type of purposes. Like in the olden days, the type of coal that is used or was used to, you can say, run the railway engines, and the other one today also that we use is about the producing the electricity, which is based on the carbon composition. Now what happens in the coal is that, first of all, the coal is being taken, it is being burned. Now by burning the coal, a steam is being produced. This steam rotates the turbines which are located in the hydroelectric power plant. Now this turbines, they gain the kinetic energy by the steam which is being passed through them. Now this kinetic energy of these turbines will be converted into the kinetic energy, sorry, the electrical energy, and this electrical energy will be stored in the transformers and then be transported through the cables, high tensile strength cables, to the nearby substations, and from that will transport again to our household, and we can get the electricity, children. Now let us now talk about the schematic of the power plant distribution or the producing power plant. Now let us talk about the generation of the electricity by studying this diagram, children. Now as I said, first of all, the coal is being brought by the modes of transport to the power stations. Now once it is being brought, it is being transported first of all to the combustion chamber. Now combustion chamber is the chamber wherein you can see, that is the next to the, you can see in the diagram, children. What happens is that the coal is being burned with its ignition temperature. Now ignition temperature meaning the temperature required to burn a substance is known as the ignition temperature, or the temperature at which the substance starts to burn is known as the ignition temperature, children. Now once it is being done, children, the coal burns, and through this boiler the steam is being produced. Now the steam which is being produced, it is being passed to the turbine shaft. Now if you look at the turbine shaft, this turbine shaft, they generate the kinetic energy with the flowing steam, we can say. Now once this turbine shaft starts to rotate, this turbine shaft will start producing the electricity, which will be generated, or we can say captured, by the generator. Now this generator will store the electricity, children. Once the electricity will be stored, children, that electricity will be transformed into a transformer. Now transformer are the, we can say, the units or the elements which converts the high to low amount of energy and low to high amount of energy, vice versa, we can say. Now there are various type of transformers, children. There is a step up transformer and the step down transformer, children. Now once this is being done, children, the transformers, they transform or they transport the electricity through the high tensile cables, and these cables, they carry down the electricity to our household as the needs or the requirements of the electricity, we can say. Now as I told you earlier also, that by passing this electricity, some amount of the electricity is being, we can say, released or being gets wasted. That is the law of conservation of energy. That is, energy can neither be created nor destroyed, but it can be only transferred from one form of energy to another one. So this is how the production of energy takes place, children. Now the next, that is about the petroleum. See, petroleum is again formed from the fossils or the degradation of the dead remains of the plants and animals which are buried in the, what I can say, the water bodies, which are being acted by the high pressurized gases. And these high pressures, without the impact of oxygen, the petroleum is being formed. Now petroleum is an extract which is being extracted from the nature, and it is found as a black liquid. Now for this, often it is also called the crude oil or the black gold. Now why black gold, children? Because it is available in limited quantity, and the uses of, we can say, this petroleum is being done on a large scale and in different modes, we can say. Now it is being heated, or this petroleum is being heated in a chamber called the fractional distillation, which we'll be studying in the later on this chapter, children. Now it is being heated to form different form of materials like the petroleum jelly, petroleum gas, aviation fuel, and tar. Now petroleum jelly is the common example that we can say is about the Vaseline. The Vaseline jelly that we apply in the winter season, as well as the petroleum gas, that is the petrol, diesel, kerosene, naphthalene, all these things that we obtain as a fuel, we can say. And aviation fuel, that is the white fuel that we say that is being used commercially in the aircrafts, airplanes, helicopters, and the other things. And the tar is nothing but the coal tar, that is the black color liquid which is used to build the roads, and which is being used commercially for the maintenance and the developments of the roads and the other materials, we can say. Now how does the petroleum being formed? Let us study, children. This is an outline of how does the oil is being extracted or the petroleum is being extracted, children. First of all, through the steam injector, the high pressurized, we can say, steam is being injected through the pipes into the hot water, we can say, into the rocks beneath the water bodies or in the oceans and the rivers. Now once it is being done, the oil is being pushed down to the nearest oil extractor reservoir. Now this reservoir, we can say, they will extract the oil, and it will lead to the offshore collection of the oil, children. Now this is the simplest form, yet in reality it is a much more complicated process, children. Now how does it is being done, children? We shall discuss in the next lecture that how the fractional distillation is being done, and by which we can get the petroleum products and the other products also, children. So I hope you have cleared with the topic, children, that I made you understand today. And in the next lecture, we shall talk about the fractional distillation and the other conceptual one. Now, so far as what we have learned today, conventional sources, non-conventional sources. Conventional sources, that is the fossil fuels, the coal, we can say, the petroleum, and the other, we can say, production of the electricity and the extraction of the petroleum from the seabeds, we can say. Thank you. Have a nice day.